All right.
Cool.
Welcome, everybody. Okay, so we had some offline discussions about the role of this meeting, but we'll get through what we have, and then we can talk about that at the end. Okay, since last week there were 59 new PRs, or since last month there were 59 new PRs merged. We have two new passes. One of them is propagate annotation. This is to take management dialect attributes, and which Hongren will give us a tutorial on after we go through all of the bookkeeping. But it will propagate those management attributes throughout the IR. And then I added a pass called tensor lineage to affine loops. This is basically an implementation of lineage ops using loops, but supporting tensor semantics. So before you had to bufferize to memref in order to implement tensor or to implement lineage ops as loops. Now you can do them with tensors. Okay, so we've had some improvements to Latigo. So there's some cross-level support from OpenFHE, like simulating the like less fine-grained control. OpenFHE does some level reduction stuff, and so we added support for that to have like the same operations be done in Latigo and OpenFHE. And then I was working on my layout thing, and I noticed the Go version was like not what I thought it was. It was like an older version, so I updated it to a more specific Go version. And then I did that because a bunch of my improvements to the Go emitter include using packages that haven't been updated in the old version. So like slices.repeat and stuff like that for emitting tensor ops are now using the newer Go standard library. Okay, so we've had a bunch of changes to the build. We added a new macOS CI and a hermetic toolchain. So now if you use Mac, you have to have a full Xcode installation, not just like the command line tools, which is kind of an unfortunate side effect. But that means that we're using the same like Mac OS correctness setup as like TensorFlow and all these other systems, because they all use the same Mac OS Bazel system. And then we also have a new CI that runs on Mac OS. So if you have a PR that you think is impacted by Mac OS, you can like label it and it will trigger the CI. I also have it running once a week to find. And then I also found a bunch of fixes that were exposed by that being broken. We also added a Clang version matrix CI. So we have, it runs versions 15 through 19 of Clang, and 16, 17, and 18 work, but 15 and 19 fail. I noticed that it's the same error on 15 and 19. You can see the error there, but also that error in 19 was patched in a minor version, and the CI only has access to an earlier like 19.1.1, and I'm on like 19.1.7 or something. So I don't know how to update the CI to use a more recent Clang version, but I think just fixing the underlying problem would be best. But then, okay, I also am confused now because the CI works for Clang, but we've had people using Clang like 19 and say it doesn't work, or like Clang 18 and say it doesn't work. But okay, I don't know. We'll have to debug people's individual issues. Okay, so for OpenFHE, we have a new feature that allows you to like build your examples directly in the OpenFHE repo, like take your HEIR compiled output and just like put it into the OpenFHE repo so you can compile OpenFHE with different like CMake flags and test different things. And then we added a crypto context options so that you can, I think the full set of crypto context option flags are now supported in the pass, and you can manually override them with pass options because the compiler is not setting all of these things, but you might want to. Okay, on the Python front end, I put in a little hack to enable like testing things, multiple tests in one file. It's quite broken, or it works, but it's not like the right solution, and there's an issue filed for the right solution, which is like to cache the LLVM generated PyBinding stuff.
It also doesn't work quite as well as we thought. It only works if the test files are in their own function, which is a weird limitation.
Right, exactly. Okay, so and then we have some better discovery of OpenFHE through Bazel that Alex added. A bunch of users have been coming to us with issues trying to use HEIR for various purposes, and things have been failing in different ways. So we've been doing a bunch of work on the CGI pipeline to support some of those use cases. And then we found a number of bugs in doing that as well. So the LUT ops were commutative, which means that the LUT input and the LUT table were swapped. And so I didn't realize this until recently. I thought the commutative operation, the commutative trait doesn't do anything, but there's a folder that causes it to put constant operands as like the left-hand side and non-constant operands as the right-hand side. So that was affecting the LUT op. And then there was also an index signedness issue with Verilog. So there's a bunch of like cleanups and improvements here for the CGI pipeline. And I think the bottom line there is that Acer is working on getting CGI into the front end. And so there will be a lot of improvements coming to support that. Okay, we removed two things, the LWE set default parameters, which is now handled by individual parameter selection passes, and then check label, which is like a testing thing. I think everyone here I've discussed it with, but there's a regex rule now, so you shouldn't have to worry about it. If you use it by mistake, it will be caught. And then we are in support of that CGI pipeline improvements. We renamed the Tosa to Boolean TFHE or whatever passes into MLAR to CGI, and then the backend is a separate pass. Okay, so we Hongrun discovered how to properly use two analyses that depend on each other within the same solver instance. So that was fixed in all the places in the code base that need it. I have been working like crazy on the layout system. It's still not quite in, but I found a lot of bugs and a lot of improvements along the way. Most of the work is actually causing expanding the support of the OpenFHE emitter and the Latigo emitter for all of the clear text ops that are lowered by doing packing. So when you're packing clear text as plain text, you do a bunch of tensor shuffling, and there's loops, and there's all this stuff. So now a lot of that is supported. There's still some deficiencies, particularly with regard to multidimensional tensors that needs quite a bit of work to clean up. So I was doing kind of the minimal thing I needed for the layout system. But yeah, okay, so also just at the higher level, I have like kernels for tensor extract and tensor insert using the like naive idea of like masking the ciphertext and rotating it and inserting it in the right place. And then I'm supported like scalar layouts and layout propagation through loops and all kinds of different stuff. So these are all like independent things I pulled out of my broader layout system integration PR. And then I added some support. So we have a Google internal contributor who wants to do more stuff on polynomials. So I have polynomial approximation now supports ReLU ops by identifying a arith max with a constant 0 operand. And so that is sort of expanding the work on that. And then in progress, I think just yesterday I posted 2 PRs that support basically adding a Chebyshev basis representation to our polynomial dialect, and then separating the polynomial eval lowerings into its own pass, so that we can use it in like multiple different places in the pipeline. But with these 2 changes, once they're in, then our this guy Vadim, he's an internal contributor, and he wants to do like, he has his I showed him all of the like Patterson-Stockmeyer things that are happening in other FHE projects in a Chebyshev basis, and he found some simplifications of other people's work, and he's like, oh, you don't need to do that, it's simpler, do it this way. And so he is going to implement the like Chebyshev, like Patterson-Stockmeyer baby step, giant step type approach in the Chebyshev basis once these PRs are in. Okay, yeah, so there's a couple more CGI pipeline improvements for Yosis, and then we're trying to make a non-Yosis compilation path work well. So those are in progress. I have some more layout system sub-PRs. My big layout system integration is still not done yet. There are 4 small test failures that I need to get in. I need to figure out. One of them is the like plain text backend is seg faulting, and so I have to like figure out like why the hell that's happening. It's very confusing to me. It's like the generated code is seg faulting, so I have to dig into that.
Maybe remref.
Maybe, yeah, it could be something, but I'll have, I don't know. I have to debug it. but it's very close to passing all tests, and then we can get it in, and I can move on to more interesting things. And then, okay, so on the some other things, so we're removing RNS of poly 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 in favor of poly of RNS on the coefficients. I think this was a long time coming, and it just required us to do some make some improvements on the polynomial dialect to support it. And then Hongren added a draft noise model for CKKS that still has some issues with it, so it's left in the draft state. But we will, I don't know how long it might take to get this in, but yeah, it's very interesting and dependent on lots of unanswered questions about how CKKS will be supported in the compiler long term. Okay, and then we still have the 2 front-end PRs in progress on adding tensor typing support and adding if statement support, which have some blockers that need to be resolved. Okay, no, anyone want to say anything about ongoing PRs before I move on to new issues?
When will we remove the BGV extract and CKKS extract?
So those, once my layout system is in, I think we can remove those, because the layout system has lowerings for tensor extract and tensor insert that do not involve BGV extract and BGV insert.
Do we lower all the tensor extract into like mask and rotate?
Yeah. I mean, and that's, well, but that's so first what happens is the like Hiko style passes run, and anything that's not converted by those gets handled by these. So in our case, that would be like, it would like do rotate and reduce for all of the like, for like the dot product example, and it would only do a tensor extract at the very end, and it would reduce, it would lower that to a mask and rotate. But it also, that depends on like the layout choices. So if the layout chooses, say, a scalar to be represented as like repeated with no zero padding, then it doesn't need to do a mask and rotate. It can just leave it as is, and then when you decrypt it, it would decode it using the like lower decoding, which would just look at the first entry and ignore all the repetition. I think what we're doing now is that when you see an extract, it gives it a layout that has the value in slot 0 with 0 padding everywhere else. And so to maintain the proper 0 padding, it has to do a mask and rotate. Or at least it has to do a mask. Yeah. So I think that like we can support both worlds, right? And we want to do the one that's more efficient, obviously. And I think once we get that main integration in, then we can dig down. Like I haven't removed BGV extract yet, but at that point we can remove it, and then we can figure out, okay, where are the gaps in what I did, because I'm sure there are still some gaps. But then we can make it so that we can say, okay, like make sure that the encoding is correct so that it gets lowered correctly. Like this is, yeah, definitely on the agenda. Okay, notable new issues. We've had Yosis optimizer pipeline issues. Thank you to the new contributors who are pointing out, kicking the tires so we can clean up the bugs. A bunch of to-dos that I created from the layout system. Like as I'm getting things in, I had a lot of cleanup I wanted to do, so I've left a bunch of breadcrumbs for that. Okay, this is an interesting one. We implemented the layout optimization, which has a conversion cost model for layout repacking. But the current model is like very simple. So there's a PR that's filed to give a more substantial cost model for like how much it costs to do a layout conversion. I think there are some ideas in that issue for how to do it, but that would be like a very good like newcomer project. I don't know if it's tagged as that, but it should be. Okay, and then we have, so there's this issue that says like add meaningful layout optimization for lineage ops. So right now it's like if we see a matvec op, we just say it's got to be Halevi-Shoup, right? No other way. And that's actually only in my PR on layout system integration where that happens. So we want to have like a more meaningful layout optimization that will say, okay, for a matrix vector multiplication, here are the available kernels, here are the costs of each one, and pick between it according to the broader cost model. So that's an interesting open problem. And then, okay, so there's an issue, I think Hongren filed this, about distinguishing between ciphertext plaintext multiplication and ciphertext scalar multiplication, which I think have different implementation complexities in some of the backends. Is that right?
Yeah, it's different.
Yeah, I mean, I'm assuming ciphertext scalar multiplication is cheaper, right? But we don't distinguish between them. So there's an issue for that. Okay, there was one of the noise models we filed an issue because some of the tests were occasionally failing, like they were flakily failing for this like independent ciphertext noise model. And that led to a discussion with the people who invented the model about the meaning of independent. So that's sort of ongoing, but there's an issue here to like, once that is resolved somehow, to re-enable the tests that were failing. Okay, so I filed an issue this morning for supporting CGGI in the front end because I saw lots of like smaller issues that were like subtasks of this. So that's there. We had a question about how to support integer arithmetic in the CKKS pipeline because we have, you know, floating point addition operations, but then you can also do integer addition. And the question is like, what's the semantics of that? Especially, I think, because we're converting integers to floats right now or something like that. I don't remember all the details, but then this, I think Alex and Hongren were discussing the semantics, the broader semantics of integer arithmetic in the CKKS pipeline. Okay. Yeah, there's some issues with the scale management system finding like unreasonable scales when you have cross-level operations and bootstrapping. So there's an issue filed about that. Okay, there was shortly after the last meeting, Jeho showed us a bunch of work he'd been doing on formal verification for mod arith canonicalization. Oh, hold on. My wife is asking me if I want her to pick me up a drink from the cafe. So I'm saying yes. Okay, sorry. So he was doing this formal verification. Yeah, yeah, right. So Jeho's been using this lean MLIR project to basically formally model the Modrith dialect and the canonicalization rules. So that was like one of our like investigate if this makes any sense, and he did it. And now I filed an issue this morning to say like, okay, here's like an umbrella ticket for what we would need to do to actually integrate this as like a proper part of the project. So I think that's like a really interesting line of work. But it requires a lot of like improvements to the MLIR as well, because we want to like automatically extract the dialect definition from our source code to lean MLIR, and doing that from table gen seems kind of infeasible. Doing it from IRDL seems feasible, but IRDL is not feature complete. So we would have to like add features to IRDL upstream, and similar for PDL. So like for example, for IRDL, for our polynomial dialect, it would not support like custom parsing, right? So like we would have to figure out how to handle that. Anyway,
I think all of the like CPP file like definitions and verifiers that we've put into CPP files have to be migrated for the dialects.
I don't think the verifiers need to be. It's just the definition of the types and ops.
Oh, okay.
And the patterns themselves, because you wouldn't be able to verify like random C++ transformations. You'd only be able to verify peephole rewrites that are, you know, individual, you know, written in PDL or IRDL or PDLL or DRR, yeah, the table gen language. So that's interesting. Okay, so then we had this issue. Okay, so the big problem with CKKS is that the noise depends in a lot of ways on the underlying ciphertext messages. So if you don't have concrete bounds on the message values and you have like 16-bit floats or something, then basically your noise models are meaningless. So we were talking about maybe looking at the more structured case of neural networks and having a way to annotate the SSA with run your trained neural network with some sample data, extract bounds at each layer of the model, and then annotate that on the IR, and then preserve it in such a way that when we lower it to linalg, we would then have like an annotation at every SSA value of range bounds on the underlying SSA values. So I was able, with some help from an internal contributor, I was able to basically do the first step of that, which is run the neural network, get the bounds exported. And now I have to figure out how to like annotate, like, because it's like Torch XLA has this like export system to stable HLO. I have to figure out how to like preserve that metadata that I generated on the IR as it gets exported. And then once it's an MLIR, I think I can handle the rest. Yeah, Wouter?
Yeah, no, I was just asking, but you're speaking about then floating point weights.
What about it?
But no, just are the weights like integers or are the weights floating point numbers?
Floats. Yeah, the weights are floats.
So
I mean, this is like
purely for
standard. Say again?
Oh no, so purely for CKKS or with an additional quantization step for all of the rest of the schemes?
No, just purely for CKKS. I mean, in theory, we could do this for everything, but CKKS is the one that has noise modeling difficulties, right? But and like nothing I'm doing here is like specific to CKKS. I'm just saying like, can we run the neural network and annotate it with metadata? So we could probably use the same tooling for if we have stuff that we want for CGGI as well.
Yeah, but the thing is, research has shown that like if you have a floating point network, you can convert it to integers with just appropriate scaling and appropriate quantization and everything like that. But that always ends up in somewhat of an accuracy drop.
Also, I think even if you do that conversion to integers, you still have like the entire integer range as your bound, right? Which like might be too big. Like, so like in like the example I was looking at, the bounds are like -20 to 20 for pretty much all of the values. And if you increase it to an 8-bit integer, you have, you know, increased your noise bound by an order of magnitude just without getting anything for it. So like I think we want the tightest possible bounds we can get. And like the only way you can do that is by running the neural network and seeing what the actual values are. Maybe if you quantized it, that would turn those 20 to 25 to -25 into like -5 to 6 or something, right? Like it would be like also really tight. I don't know, but I haven't thought at all about doing quantization for CKKS specifically, because CKKS scale encoding is also a kind of quantization, right? So like.
Yes, you can somewhat increase it. Like you can say, like, okay, we can train now a network with quantized weights to put it, but then you go to fixed point arithmetic during your process.
Right.
But anyhow, then you will do fixed points with a precision of 30 or 40 bits because that's the scale of CKKS. And like I think the outcomes will be very limited, or like the reduction in accuracy will be quite limited.
Okay, but yeah, so I'm gonna keep like chipping away at that as I have time. On this issue, I also posted there. I found some tools that are like from the neural network community that do actually like formal modeling. Like they don't just like run the neural network and give you things. They actually use like sophisticated optimization tools to give like provable bounds on intermediate nodes, and they use this for security issues somehow. I'm not exactly sure, but like all of the repositories say like, oh, it's for like neural network security, and I think they mean like making it so that users who provide like crazy inputs will not be able to like glean anything about the secret model weights or something. I don't know. I don't know too much about it, but apparently there's like a bunch of research literature around this question. And so I haven't had a chance to try those tools, but I thought it might be nice to just try those tools. And if you just run them on the model, maybe they will give you provable bounds as well that could be used as like worst case versus average case. Anyway, okay, so then there are a bunch of research synthesis things. So there's a paper with a novel TF-HE encoding that uses like mod P arithmetic to avoid doing as much bootstrapping. I kind of didn't take a close look at it, but I thought it looked interesting. There's this new matrix multiplication kernel that was presented at FHE.org. There is a scale management paper that looks interesting. There was another presentation at FHE.org about doing parameter selection by, instead of using the LWE estimator and having like a lookup table, instead they take the attacks or basically they just like curve fit. You can think of it as like they take the LW estimator table and then they curve fit it, and then you just use the formula for the curve instead of the actual estimator lookups. So that seems like it's easy because then it's just you do a little bit of numerical analysis to like get the value on the curve, and then you can just put that right in your compiler, and you don't have to like do more sophisticated stuff like run LW estimator. So I thought that was an interesting paper. That's also by the same folks doing all the noise modeling stuff. I don't know how to pronounce her name. Chira.
Yeah. It's a very
Beatrice.
Beatrice.
Yeah.
Beatrice and Sergey. They're actually old students from ours.
Oh, cool.
They went to come visit to us, to be precisely.
Okay, and then okay, there's a completely unrelated to FHE. We're working with a guy internally who's doing ZKP on TPUs, and so he was using Pippinger's algorithm for like optimizing elliptic curve math, right? Like and I was drawing an analogy to polynomial approximation or polynomial evaluation, where right now we're doing polynomial evaluation kind of separately for each polynomial. But if you have lots of polynomials and a common input, then Pippinger's algorithm will give you a joint optimization over the multiplicative cost of doing all of them. I'm not sure if it's multiplicative depth, just multiplicative cost, but I thought that might be like a good, like, I don't think we have any use cases where we have lots of polynomials evaluated on the same input, but like, that's just like a completely lateral research direction. I was like, oh, maybe there will be a time when like we could do this and that might provide some benefits. So I just kind of filed that away as an idea. Okay. That was all of the paperwork. I wanted to emphasize before I hand it over to Hongren that we have lots of new users trying, like I think in the last week, I've seen like 7 or 8 GitHub and Discord usernames I have not recognized, saying they wanted to try HEIR or trying HEIR and failing and posting problems about it. So I think I want to encourage us all to help these people and iron out the bugs and try and get things clean, because the first impression is very important. Okay, so I'm going to pass it off to Hongren now to give an introduction to the management dialect.
Okay. Okay, can you see my screen?
Yep.
Okay, so today I'm going to talk about the management dialect and parses. So today we are going to talk about the dialects and the parses. The parses including 2 parts, the level management and the scale management. So let's talk about the dialect first. So management stands for management. So as you can see in the diagram, we have all the upstream MLIR and we have all the FHE schemes. But between them, we have a dialect called management. Because in relearning with arrow schemes, they have management operations. But for users, they don't want it because they only want to input a arithmetic IR. But for the backend, they want a scheme IR. So it's compiler's duty to insert all the management. So, but before lowering to the scheme, we need to model the management in some way. So management dialect is a home for them in a scheme agnostic way. We have mode reducing, which stands for rescaling for CKS, and modular switching for BGV, and we have relinearize and bootstrapping. Now let's go through an example. So suppose we have an example of user input and we have a squaring of it and return the result. So the user input is simple. So it inputs arc0 and with a multiplication of it, we get the result. Now, for HEIR needs to know what is the secret computation. So it will wrap everything in a secret generic OP and saying, hey, these things are in secret. Now, the management will come into play and say, okay, we need all the ciphertext properties like the level and scale. So the first pass will determine the level of it and we'll manage it. So it will insert a mode reduce for the multiplication, and it will determine all the levels of it. For example, for the input argument, it has level of 1, and for the result, it has a level of 0. Then after the level analysis, we have a pass that deals with the scale. So because in CKK, the scale is important because and after multiplication, the scale doubles up, and we need the mode reducing to rescale it back to 45. Then we have all the scale information. Now with all the level information and scale information, we can go to the scheme dialect. So in the scheme dialect, we can see that it's a CKKS multiplication and a CKKS rescale, and all the backends are happy. Okay, any question on the example?
So one thing I think that part of the reason that we're doing the management before the scheme is that we need to generate LWE types when we convert to scheme dialect, and some of these attributes are necessary to know at the time that we generate those types.
Yeah. We can
so like-
load to
so like-
scheme and load to scheme.
Right, like so if we were to lower the scheme without knowing like the ciphertext dimension or the level, then it would be a lot more difficult to generate the LWE types, or we'd have to generate some like default types and then go back and like change them again when we have decided on all of this stuff. And so that's a big part of the motivation for why we're doing management at a high level before the scheme dialects.
Okay. Okay, now let's go to the second part. We have management passes. So the first part is the level management. So if you have used the OpenFHE, you know an API called set multiplicative depth, where you are asked to specify the level of your circuit. So in compiler, we need to do the similar thing. But the compiler can compute it via this pass. It does so by inserting level management OPs and annotate the level. So after all the level annotated, we can get the max level, and we can use such level for this API, and we can do parameter generation. This path has various variants like for different schemes, because different schemes has different policy. Because for example, BFE does not have level management, and this path also does other things like linearize. And this path is also responsible for the bootstrapping placement, but we don't have a very good policy for it now. This is a big to-do. Now let's go to an example. So the main thing I want to talk about this path is that we have 3 styles of rescaling. Let's go through the example. This example is a multiplication of the x and y, and after the multiplication, we get a squaring of it. But as you can see in the example, the scale blows up. So in the end, we have 180, the scale of 180, but in CKS, such thing is not quite allowed. So we need rescaling. But how do we do rescaling? We have 3 different styles. So the first one is after multiplication, and let's introduce one by one. So the first one is rescaling after the multiplication. As you can see in the right, we place a rescale after each multiplication. This is the textbook way. So with this, we can control the scale back to 45. Another note is that rescaling for BGV is to control noise, but for CKS is to control the scale. The important thing about this part is that between these 2 multiplications, the blue area has small scale, so the scale of 45. Then let's see another style. So in this style, we have the rescaling placed before the multiplication. So if you have used OpenFHE, you know that there is a mode called flexible auto. So this is the same way that the flexible auto does. The big difference between this one and this one is that the in-between scale is big now, and it has a benefit. Like if we are using another circuit and we are doing like addition and rotation in this area, the noise can be hidden by the rescaling after it. And this is the default way of inserting rescaling operation in HEIR. Then we can go one step further by, in OpenFHE, this is called flexible auto extended. By inserting rescaling before the first one, including the first multiplication. So the benefit is that it has even smaller noise, but the penalty is that we have one more level. There is 3 levels of rescaling, and we have 3 levels, and we need to encrypt at a you can see the orange subscript here. We have to encrypt at a double degree. So we have to choose that. We have to have a choice. So any questions about these 3 styles of multiplication? Okay, let's go further. Now with all the level management, we can do scale management. So why this is a standalone path is that the level management path only inserts these operations, but we don't have concrete values like the concrete scale value. And only after the generate parent path, which relies on the scale, which relies on the secret insert management, we can ask the user for the default scale, and we can now know the scale. Then this path is responsible for populating the scale to all the ciphertext. So you can see all the subscript here is populated in this path. Also, another important aspect of this path is that it also handles cross-level operations. Let's see an example. So in this example, we have a multiplication of x and y. And in addition to that, we have an addition of y. So this is a circuit for that. And the problem with this circuit is that after multiplication, you have a scale of 90, but your y is only of the scale of 45. So there is a mismatch, and we can do addition of them. Then in here, we do another OP called adjust scale if we find the scale mismatch. So this is inserted and with an unknown delta scale. Then to determine it, we need a scale analysis to determine what's the value of the delta scale. So it has two phases. The first phase is called the forward phase. So you can see that you can propagate from 45 to 90 to 90. And you know that for addition, we have a scale of 90, but for y, it has a scale of 45. Then a backward phase propagates things back from add to adjust scale, and you can calculate the delta scale. So it's 45. Then because adjust scale does not have a corresponding operation in the scheme, we lower it to a multiplication of y and 1. The 1 is scaled by 45, so it's a plain text, but with a 45 scale. And this operation does not change the message itself because it's a multiplication of y and 1, but it does change the scale. And now you can see we have a scale matching. Okay, that's all of my talk. Any questions?
Does it make sense to have a just scale, or maybe it's a scale up operation at our dialect level, even if it's not supported in the back end? Or do you think this is simple enough?
I think scheme level dialect does not want to see this because the analysis does not like it. We want a simple one.
Okay, I was just wondering if maybe there's an optimization that we could do at some point that because right now I notice we don't have any real optimizations at the scheme dialect levels. We're moving. I think originally when we designed the scheme dialects, we thought we would be doing a lot of these optimizations at the scheme dialect level, but now we've decided we're doing them before, and there's not really any optimization passes that happen at the scheme dialect level. And so I was just wondering if maybe there's extra information that you would have at the scheme dialect level that might allow you to prune away some of these scale adjustment operations. Because for example, it's a multiplication by a constant, right? Effectively, or I guess it's a plain text, so it's not quite a constant, but yeah. Okay, I'm sort of just speculating here, but maybe I think what you have is very good. But I was just wondering if maybe materializing it as because if you just see a multiplication by 1, you can kind of infer that is a scale adjustment. But if you preserve the information of the purpose of that op, then we might be able to do some more simplifications later once we have more information to get rid of it.
I think that's the responsibility of another path that does all the scale optimization before the scheme level.
Mm-hmm. Okay.
Okay.
Now, you were going to say something, Asra?
Yeah, in a similar way about this multiplication by 1/scale thing, is there, if you have I think this is on 2 or 3 slides before this one, maybe, there was the picture you had of doing scale before muls, right? If you have inputs there, user inputs or plain text, can you fold in that rescale before you encrypt? Or I guess you're just encrypting at a different level, right? That's all it is.
Yeah, we have a back propagation pass that can do all the thing back to the input.
But we
Okay.
don't do a folding, right? If you have like a rescale op of a user input, or okay, the easy one is if you have like a rescale op right after an encryption op, we don't have something that folds that into a single like encode at a different scale. Like that's ideally what we'd want. And then the more complicated version is if you have like a function argument that you somehow know is a user input, right? Putting aside the fact that we might have multiple functions calling each other, ignore that for a bit. You know that it's like a straight user input. We would want something that like when it's generating the client side interface would be able to move that computation into the client encoding step rather than have it be like the first operation that happens on the server side.
Right. Yeah, I guess
I mean,
it's the same question about like the layout propagation too. Like, is there a way to say that that's cheaper than doing the rescale later? Or like you should push to have that be folded into the encoding rather than performing it on the server?
Yeah,
I think you always want to put it into the encoding if you can, right? That's always going to be cheaper. And we don't do that for layouts either, right? Like we're going to need to solve the same problem for layouts where if you have your user input and it's immediately converted to a different layout, then you want to instead fold that into the original layout choice. Yeah, Alex.
And I think we might even have an issue for this. We also need to push any sort of intermediate inputs from the server to the client in for hardware accelerators where you can't do encoding on the server, right? Or like, or I guess you not necessarily to the client, but you have to push them out of the main sort of. So I think we probably want some kind of like not too hacky way to reason about pushing things between the like different functions. And then we can reuse that for all of these, like at least these three, but probably even more as we go through it, right? Kind of like propagations.
Yeah, this is all sort of tangential to the main point because I think the Hongren's work is really cool. I love the like forward propagation to meet at the adjust scale and then backward propagation to meet in the middle. I think that's a really slick design.
I have one question about the adjusting scale lowering, right? Because you say we should lower this to a multiplication by 1. How are we certain that isn't going to disappear, right? Because like multiplying by 1 seems like a thing that we would optimize away at lots of places.
Because one is encoded in as a plain text, right? So it's not a static.
Yes, but like the point like this, like somebody could still very reasonably write and like a folding pass that would get into and like that would get approved as a PR, which is check if a plain text is all ones, and if yes, don't do the thing, right?
Okay, that's the tricky part of that PR. So in detail, we have a management INIT initialization OP that stands for the encoding OP. So that's in between the modification and 1. So here it says the encode. So the encode here and stops all the folding.
But like at the secret arithmetic level, you literally have an arith.mul. I guess no, but at the secret level, you have a management adjust scale because you can't write arith.mul by 1 because that would get canonicalized away, right?
Right, exactly. And
Okay,
there's a management
right? What does it get lowered to?
It get lowered to encode. So there's the arith constant 1. There's the encode op, which semantically means it's no longer static. So it's a plain text, right? And then it's encoded with a particular scale. And I think the better answer to your question,
as long as we have to be very careful that we never make the encode thing take part in constant propagation, basically.
Right. And I think the better answer to your question is we have tests that will fail because the scales will mismatch and it will run the resulting program and give you the wrong answer. So we're not going to check in anything that does that.
I know, but I think my point is more like, right, like this is a sort of like brittle, like if you're relying on something not getting canonicalized away, but I like the idea that as long as the encode op doesn't produce something that's constant like or can be constant propagated, it's fine, right?
Right, exactly. Yep.
I also have another question.
So we have a special OP for that. The management initialization OP dedicated for not getting canonicalized away.
Yep. That's like to set, that's before we have encode, we like set scale basically, or set level or whatever from the input.
Okay.
Yeah, maybe for the last few minutes. Oh yeah, Wouter, go ahead.
Yeah, I also had another question, but this is purely because I'm not inside the CKKS world. But for me, it feels like adding a multiplication. That's always something that in the CGGI world we really don't want to do. So how
it's a plain text
costly is it to
multiplication.
do a multiplication instead of a scale adjustment?
Well, so it's a plain text multiplication, so it's like a little bit cheaper than ciphertext multiplication. But like it's not as cheap as like multiplying. Like I think it's like a proper plain text multiplication, not like a scalar ciphertext multiplication, right? So it's like it is not. Oh, it's treated as a scalar.
Or, yeah, you can do that, right? I thought the CKKS.
I don't know.
So that's something about the. So you can see in the distinguished ciphertext plaintext OP and ciphertext scalar OP difference. So if we multiply with a plaintext of all ones, that will be encoded to a scalar. So that's like the math.
Oh, you're saying that's OpenFHE like matches on that, or
no? That's the math part, because if you have a plaintext of O1, then after encoded is a scalar.
Oh.
Because of DFT.
Ah, yes. Right. Exactly. It just ends up, okay, that makes sense. Oh, interesting.
Ooh.
Yeah, that didn't come to me until I play with that.
That's very cool.
Yeah, okay, but then it's indeed relatively cheap.
Okay, how about for the last 5 minutes we talk about, okay, well, I wanted to, if we had time to talk about like any follow-ups from the conference that people wanted to advertise, but maybe it would be better to talk about next meeting. So like, why don't we pick someone to discuss, to like give a similar like half-hour presentation on the topic of their choice, like an overview of some work that's been going on. If nobody else wants to volunteer themselves, then I can talk about the layout system.
Okay, one minute.
Okay.
I think that's by far the most complicated. I think those two are by far the most complicated things currently going on, right? So I think having some early documentation does be great. I think also Hongren's talk visualizations would make an amazing like documentation page. If you basically glued them underneath each other in a like HTML page, and talk a bit about.
There is a documentation page on the management system or on the noise modeling, right? And I think a lot of that covers the same ground, but
yeah, there's a design doc on ciphertext management.
Yeah, so I think that covers it. Maybe there aren't as many pictures as in the slides.
But I know you can also. I know there was also some project to just convert the LaTeX code into Markdown code, and then you can just basically
just PDFs or PNG. And my point was, I think really that documentation page could really benefit from having some of the like rescaling pictures, for example, right? Like the way you explained that, or something like. Yeah, I think you drew all these lovely pictures. Let's not just hide them in this recording, right?
Yeah, well, I'll also put like a link in the docs to this YouTube video that gets like to like the timestamp in the YouTube video, so we can have that there. And then if you could link to the slides, that would be like probably the simplest starting point. And then if you have the time, you could also take some screenshots of your slides and put them in the docs themselves. But I think that's extra.
I just put the slides there. Just put PR that into the repo.
Sure.
Okay.
Cool. Okay, then does anyone have any things they want to advertise from the conferences? Because we didn't meet since before the conferences happened.
Maybe quickly that tomorrow, in 25 hours from now, to make it less time zone specific, we're having a follow-up meeting from some of the hacks conversations and sort of Rework Crypto Week conversations about people that build crypto-ish compilers. So mostly this is ZK folks, but I think there's also some people that are more interested in how to compile cryptographic code with LLVM MLIR and have it not be horribly side channel leaky. And then there's at least, I guess, Jeremy and me from the let's compile some FHE circuit side. And I think half of it is like a support group for traumatized cryptographers working with MLIR, and half of it is trying to actually standardize and come up with some circuit IR representations for ZK things. I don't know what the best way to link to that is. I think there's an invite link for the Signal group that I can add to the Google Talk.
Yeah, I don't even have it on my calendar right now.
Yeah, I think it's there's just a message, not an invite. So it's tomorrow at 10 Pacific.
Okay.
About the ZK compiler, so Alex, I know there is some work on ZK from your side. Is there any possible integration?
No, I mean, I've worked with, like, I've done applied crypto papers that use ZK, but those generally didn't really use compilers in like our definition of compilers, right? I mean, I don't consider Circom to be a real compiler. Sorry, Circom people. But ages ago, I did try to do like some ZK thing with MLIR, but that was during my PhD and that didn't go anywhere. There are a lot of really cool ZK compiler projects, including one that uses MLIR, or at least one. I think there's 2 or 3 now that use MLIR. One of the issues with the ZK community is that it's not super open to the same kind of open academic collaboration that we're doing here, because there's so much money involved, right? All of these compilers are maintained by companies who think that this is their big ticket. So it's a lot harder to get them to actually share code or even come together and do useful things together. I also don't know if anything that we do in HEIR is like that we do in HEIR because of crypto reasons is reusable. But one of the things that they were really interested in is like how we use attributes to annotate analyses for like easier debugging. So like the management annotation, the secretness annotation. So I think it's going to be mostly, as I said, right, like a bit of MLIR support group, exchanging little tricks and techniques. And I guess they also probably have similar issues to us where they have a discrepancy between like the arith level semantics and the semantics of their actual program. And I think that will be another interesting thing to talk about. How are they expressing that to users and how are they dealing with it internally? So yeah, I think just lots of shared pain points, but not necessarily shared like techniques or optimizations.
Another question is that I know there is a ZK OpenFHE is that does the computation and generates a proof. Is that integration possible from HEIR? Like we also want a circuit that has a proof.
Okay, so ZK OpenFHE was a student of mine, right? He's now a PhD at EPFL. Yeah, that project is cute, but I think if you want to generate a good ZK proof on FHE computation, first of all, you have to do a bunch more crypto innovation. But then also, I think it's probably not, like the compiler part is probably not going to be the hard part. It's going to be to actually find like a constraint system or a proof system that works. I think eventually, if somebody comes up with a ZK proof for FHE computation that's fast enough, I think it would be fairly trivial to extend HEIR with that, right? Like the compilery parts of that aren't necessarily the hard part. It really seems to be the crypto.
Okay.
But yeah, I mean, like targeting ZK OpenFHE, for example, I don't think, like we could probably like hack our OpenFHE backend so that it could also target the ZK enhanced version. But I don't think it makes a lot of sense because ZK OpenFHE is so slow, right? The like proofs it generates are not very practical. And there has been a lot of cool work in this area since then that use much more complicated lattice-based crypto things. So I think if you wanted to do something in that direction, we should do, work using that. But the problem is there's like 1.5 implementations of these things, right? So I think it's a bit too immature right now to do FHE ZK.
Okay.
Actually, Jeremy, I think did you talk to the Zama folks about, like, because they have a ZK thing where they proved like CGGI bootstrap or something with Plonk or something, right? And I assume they did that manually as well and not using Concrete and the compiler infrastructure.
No, I had talked about maybe having like an MPC backend for HEIR and then like using garbled circuits. And then I'd also talked about having a proof of decryption for LWE and RLWE, with that being like when we have those situations in which the user or the server needs to know the output of the user's circuit, right? Then like the server would run the FHE computation, send back the ciphertext to the user would decrypt it and provide the decryption along with the proof of decryption back to the server, so the server could do something with it, while also because the authentication is an example. You do a thumbprint on a reader or whatever. The server doesn't want to see the thumbprint, so it does the thing, and then you just need the one bit: was it successful or unsuccessful? And then, but you have to make, the user, you can't trust the user is going to tell you honestly what the result of the decryption was, so you need the user to provide a proof of decryption as well. And so that's the kind of situation where I thought formal verification could be useful, but that's not, the compiler's not optimizing anything there. It's just like emit some code that does generate the proof and emit the code. And you're not, like, a compiler doing optimization would need to, do something meaningful about balancing who's doing what computation.
I just realized one thing, which is that if we wanted to eventually support like proof of computation, which like proof of decryption and encryption, those are like super practical now, but proof of computation is the one I mentioned, right? That's super slow. That would probably impact how we want to do management. So there might be a cool paper in a year or so for you to write on this, where we say, hey, now that we want to add ZK because somebody finally came up with a proof of computation system that doesn't suck. What we found out in our work very early on, cost model changes completely. Your ciphertext management operations are now bad. Nope, you don't want to do it. Just crank up the parameters. Just don't relinearize. Don't mod switch. Don't do anything, right? Just make it the worst managed FHE thing possible, because it's so much faster to just in parallel crunch a few more RNS limbs than it is to do complex operations under ZK or to prove them, right? And so I think that would be maybe an interesting thing for the actual compiler to do, is to say, hey, if somebody comes up with a proof of computation system that's good enough, implementing it as a backend is one thing, but the more important part is actually getting the compiler to spit out sort of ZK-friendly code that doesn't do a lot of management, right? So that might touch on something like, today's topic. Really only do ciphertext management ops if you absolutely have to, because you're running out of parameter space, for example, right? So I think there might actually be some interesting, compiler design work in this, but I think most of it will only become relevant in the next generation of these lattice-based proofs of computation, because they're getting a lot better, but better isn't good, unfortunately, at the moment.
All right, cool. Well, I will stop the recording.